Network Earthing and is now the Director of Safe Earth Consulting. He has extensive experience in earthing system design, audit and testing, lightning protection and induction risk management across a range of industries, and has been a regular lecturer at ESAA earthing courses. Stephen is the co-author of the paper Earthing System Design, Moving from the Worst Case to the Big Picture, which he presented at the B3 and D1 colloquium in September last year. We'd like to thank Steve for his time and making the Q&A session today. Substation earthing, personally I find, is a very interesting safety concern, and it's one that draws a lot of debate within the power, transmission and distribution industry. So I look forward to hearing more from him today. And I'll hand it back over to Ben to get the Q&A session underway. Thanks very much, Ben.
Okay, thank you, Matt, and thank you very much, Stephen, for attending.
My pleasure.
First question, no, thanks. First question is titled Appetite for Risk. So based on your experience and expertise and the work you're doing in this large-scale scenario risk modeling tool, which you presented at the B3 D1 colloquium, what are your thoughts on the minimum requirements imposed by the IEEE 80 and EG 0 standards? Do you feel they're too risk-adverse or that they need to be more risk-adverse?
Okay, thanks, Ben. So that's a pretty good question. It cuts to the heart fairly quickly. What was wrong with what we were doing? That's a good question to ask. You know, engineers aren't in the business of changing things for the sake of it. You know, we'll leave that to other trendsetters. My experience over more like 15 years of earthing design was that the traditional requirements seem to be appropriate in the bulk of the cases, but there were a bunch of cases where they clearly weren't appropriate, and that was leaving me as an engineer with that sick feeling in my gut. Okay, now they weren't easily described as more risk averse or less risk averse. What would happen, now let me start with the IEEE 80 criteria. So what we've got in there is a formula by Dalziel that tells you that we have a current sensitivity in the body and that we have a body impedance of 1,000 ohms. Now he multiplies a current sensitivity curve by a body impedance of 1,000 ohms, and he comes up with an allowable voltage, which is called the safe touch voltage. Now he determined from the data that he studied that there were two current sensitivities, one of them that represented more or less the whole of the population, and he referred to that as the 50 kg criteria, and he had one that represented more or less the workforce, and that was referred to as the 70 kg criteria. Now even those facts, how Dalziel did it, what came out, isn't well understood. In Australia, the IEEE 80 criteria were replicated in EG1, which is quite a good document. They were used for a long time in Australian Standard 2067. They were what most of our assets were built on for a long, long time. Those voltages were applied almost independently of where the voltage occurred, what people would be in the area, how often faults occur, and all these kinds of things. But on average, they weren't too bad. The places that were bothering people like me who were regular practitioners were things like we would do, say, a distribution sub in a small rural area, and if someone wanted to be picky, they would say that the 2067 criteria that was based on IEEE 80 required a touch voltage to be brought down at a pole or a fence or something to, say, 300 volts, okay? So it might have been 400, 500, 600 volts, and if you use an absolute voltage criteria, it says that you have to bring that down to 300 volts. So in some cases, there'd be tens or even, hundreds of thousands of dollars spent to bring touch voltages down in locations just to meet a voltage criteria. Now, it seemed, the gut feel of myself and other engineers was that seemed wrong. It seemed like a bad investment. But because it was a black-white voltage criteria, then you either spent the money and lowered the voltage, or you turned a blind eye to it. At the exact same time, and possibly even fed out of the same zone substation, we had things like swimming pools, and we had things like the fence at the bus stop out the front of a primary school, where the touch voltage was 290 volts, and therefore compliant with this 300 volt magic number for whatever clearing time that and soil resistivity that equates to, and therefore people would spend no more money lowering that voltage further. Now, in actuality, if you had 600 volts on one pole out in a rural area with no people around, or you had 290 volts in a swimming pool or the front fence, adjacent to the bus stop of a primary school, which place is better to spend your money? And the gut of the engineer often leads the proof positive that they were right. And we felt like you should have been spending the money at the primary school. You should have been. There were various places we found when we were doing testing that we said, I'm not comfortable with this, but I am comfortable with that. So that's really the thing that's led to the risk-based assessment. The starting point was to say, if my gut tells me that we shouldn't spend the money, but we should spend it. We shouldn't spend it in the rural area. We should spend it at the primary school. Why is that? Why do I have this feeling that I'm uncomfortable with it? And it came down to what I considered the risk almost intuitively to be. We then had to come up with a way to calculate the risk so that we could measure whether our gut was right or wrong. And that process of being able to calculate the risk, that was the work of Bill Carman and his PhD, and that work has been paramount in us being able to apply it across the industry. And a significant amount of EG0's risk calculation process was an evolution from Bill Carman's PhD work. So in this question, there's IEEE 80 and there's EG0. They're quite different in terms of their minimum requirements. IEEE 80 was a fairly simple allowable touch voltage. EG0 is saying that really, if you want to be rigorous, it's a risk-based approach to manage risk evenly across things. And that to me is the big difference, and that's why we're heading in the right direction, because we're actually empowering engineers to say this is good use of the funds available and this isn't as good a use of the funds available.
Great, thank you, Steve. I think that really highlights the need to work out why the standards are saying what they're saying rather than just following them blindly.
Look, I would agree. Let me just say one thing about the traditional voltage criteria. Many people consider them safe touch voltages, and they think that that would mean that if you were exposed to it, you would survive. And I can't say it clearly enough that for every one of those allowable voltages, whether it's from IEEE 80 or whether it's from IEC 61936 or from Euronorm 50522, for every one of those allowable voltages, there is still a probability of fatality if you stand there and touch it when the fault happens to occur. So all of our safety criteria, even the traditional voltage criteria, had some level of fibrillation risk, and all of them were relying on there being some level of unlikelihood as to whether you would be there when the fault occurred.
Yeah, all right, well thank you for that. This question we might ask in two parts because it's a fairly long one. The first part is about, I guess, sort of non-specific phrasing in some of the standards, like as low as reasonably achievable, reasonably practicable, grey area in the risk. Do you have an opinion on what they're actually saying?
It's a very hot topic at the moment. There's been discussion amongst a number of senior people in this field around what the wording should be in 2067. So there's three phrases that are being discussed: ALARA, ALARP, so we're using practicable or achievable, and there's so far as is reasonably practicable. So the so far as is the trending wording. It's the wording that's come up in the safe work legislation. It's the wording that's being pushed by a number of consultants. Those of us who are practitioners rather than consultants in risk, we're seeing very subtle differences between them that some people seem to be very confident aren't subtle differences, that they're huge differences. The best way probably to summarise the difference is ALARA and ALARP are both almost interchangeable. Okay, I don't think anyone's going to be offended at that. The so far is seems to achieve exactly the same outcome. Okay, both of them are trying to achieve what's reasonably practicable. Reasonably practicable being where you've done everything you possibly can unless the cost was disproportionate to the risk. Now, that's interesting as well. The wording is often cost disproportionate to the risk or grossly disproportionate. My thinking is that it should be the change in risk achieved by the expenditure rather than the absolute risk, which is not clear when lawyers talk about it. But that fundamentally is one of the problems. I think lawyers don't have to measure anything and engineers have to measure everything. So we're left with this application of something that doesn't have a scale, but we have to apply it to things that we absolutely have to measure and justify. Now, the subtle difference between ALARP and SFAR is, in my understanding, is engineers have been largely the appliers of ALARP, and what we've always said is that we're trying to get something as low as is reasonably practicable, but there's a point at which we don't bother testing more things to see whether we should make it lower. Okay, so we'd have some absolute scale where we would say that risk is low enough, we're not looking for more things to try and make it lower. Now, I think any expert or any competent engineer practicing in his core competencies, and let's face it, that's the Engineers Australia Code of Ethics, we're only meant to work in our core competencies, would, by the time we get to an ALARP study, have already implemented all of the controls and all the preventative measures that we would think are reasonably expected and that would normally be applied. So in my mind, those things would have come first before we get to an ALARP study, but the proponents of ALARP and a VG0 have suggested that those kinds of caveats, those kinds of declarations are only an afterthought targeting legal protection, that it's not really fundamental to how we operate. In contrast, they seem to be saying that so far as is reasonably practicable is 100% focused on the assessment of all known precautions. So what they're saying is that so far as gives you a better legal defence as long as you can show up front that every available precaution or every known precaution has been assessed and you've either implemented it or you've demonstrated that it's not reasonably practicable, and the principal demonstration is that the cost was grossly disproportionate to the risk. So I don't know. As engineers, do we think that's fair or do we think that's too sharp? You know, we really are in a funny place where we know that safe has no zero value, but the lawyers do believe that safe's a zero value. They say safe is where no one died or no one was seriously injured. That is only achievable in hindsight. And as a profession, engineers always have to look forwards, and as a profession, lawyers nearly always get to look backwards. So we're in a tough spot, and I think there's some good debate going on amongst the engineering community about, you know, how we're going to address this. There are other countries in the world where if they comply with the legislation, if they comply with the standards in their country, then they're protected in a court of law. In this country, we're not. The test still comes back to what else could you have done, and in hindsight, should you have done it? And that's a pretty tough position for us, I think.
Yeah, definitely. You touched on the second part of the question, which was exposure to lawsuits. So I might just rephrase it a bit. Do you know of any cases where these terms such as low as reasonably achievable or practical have actually been tested or analysed in court? And also, where you mentioned that lawyers will often say that zero risk is the acceptable risk, does the risk for engineers then become not achieving zero risk but achieving a low risk of a lawsuit?
Look, I think that's a fairly logical conclusion, but it disappoints me greatly. You know, as engineers, you know, we're in this position of adding value to society. Everything we do, you know, is of a greater benefit to mankind than what it costs. if we spend our time trying to make sure that we're not going to end up in lawsuits rather than genuinely adding value to real world things, then, you know, it's not quite as good a job as I signed up for. Sadly though, you know, it does look like to a degree that's what we've got to do. We've got to understand what those risks are. I've spoken with a number of more experienced engineers than myself about these types of questions, and they largely seem to fall into two categories. Some of them have become legal risk averse, and they don't want to go near any decision that could end up putting them in court. So they will actually, over their careers, they've shied away from places where they would be clearly responsible for what they've said, for what they've decided. The other camp, which I tend to probably relate to a bit better myself, are those who've said, look, someone's got to make the decision. We're actually making the world better for everyone, and, you know, the lawyers will do what the lawyers do. You know, if I've got to go to court and I've got to tell the truth and explain what I did and why, then so be it. You know, I personally am in that camp. I know that what I'm doing every day is what I believe in, and I'm working very diligently in my core competencies to deliver the right outcomes. And, you know, if I'm going to end up with some lawyer misrepresenting what I've done and why, then I'm going to, you know, defend myself. So I can't say any of us aren't at risk of going to court. What I can say is that for me and my team, for the 22 engineers that work here, we've decided we do want to be held responsible for what we decide, and we're going to make sure that we've got our own processes for checking and qualifying what we've done and why, so that we can actually be in a position to say, to defend ourselves. Will it work when it gets to court? I think there's a reasonable chance it will, but that's not going to be the biggest driver for me in terms of what I do. I'm far more interested in getting the right outcome for society, for the client and the public and all the other stakeholders, than I am trying to make sure that I'm in the best defensive position should something go wrong.
Great, thanks Steve. I think that's a very thought-provoking topic for young engineers, especially when we come to realise that engineering isn't all performance and specifications and involves lawyers and liability as well.
Yeah, and it's not black and white. You know, a lot of us young engineers, and I was one once, you know, we were attracted by the black and white nature of science and maths. But when you apply science and maths in the real world, there's a lot more greys than I would have thought when I was, you know, in high school.
Yeah, thank you. The next question is about fault current. There's some background about Ergon's procedures there, if you'd like to read them as you answer. But main question is, when you mentioned that distribution faults, the traditional analysis is to add a 1 ohm impedance to the bus fault condition and take that as the worst case. What is the justification for that? And how do you find the balance for the greatest risk fault, which may not necessarily be the highest current?
So yeah, again, this is a good question, and it is a correct insight. I'll completely agree with the last sentence under the background. When you move away from the sub, the fault currents will come down, and the clearing times will go up. So that's true on every feeder out of the substation. So any secondary fault from a major sub or a zone sub has all these fault scenarios, and it's all those different fault scenarios are what we're combining now in our cumulative risk assessment on major subs. So if the author of this was suggesting that, you know, isn't it better to look down our feeder or feeders, and for each one of them work out what the best, well, what the worst case was, based not purely on the maximum current, but based on the worst combination of current and clearing time. Okay, now that's true, and it's fairly easily applied if you're using strict voltage criteria, traditional criteria like EG1. But that's not the worst case for everything, because you've then got to turn around and say, well, I've also got to comply with telecommunications coordination. So that no longer is clearing time. It's the class of the substation. There is a clearing time factor in it, but it's largely class of the substation and its reliability, and then it's just an absolute voltage. So if for some reason you had low fault current on the primary, your secondary was your worst case in terms of current magnitudes. You had clearing times in a bit of a range that meant you had to be in a certain class. Then the only thing that matters now is where your 430 volt contour is. And it becomes less then about, oh, the current got less but the clearing time went up. It's more about where was the maximum voltage transfer or voltage gradient transfer. Similarly for other criteria like for stressing telecommunications equipment or for pipeline interference. So I would say that the idea that I'll look down my feeders and get the worst case for step and touch voltage compliance is a good one. But even before someone started seeing that and thinking that through clearly, the documents published, we're just going to do the major sub. We're not looking at what's connected outside it. They probably were considering that what's connected outside it might not be there to start with, might change next year, next week, the year after. And so we can't rely on that so much as we can rely on the zone sub, and that there could be a worst case. So I think what it sounds like Ergon's doing is an improvement. It's always good to consider more things, even if you can then come back to a simple assessment of them. It's always good to consider them all. How do you justify bus plus 1 ohm? I think the main way it was justified was by saying, I'm the substation engineer, I don't know what happens once the feeders leave the sub. And that really is where a lot of the earthing management came from in the first place. To attend an IEEE 80 meeting, there's 9 foot outside the sub they care about, and after that they just don't. Not even worried about step and touch voltages beyond the fence in many cases. Something that is changing, but that's the kind of background, I guess that's the context in which bus plus 1 ohm seemed reasonable to them.
Okay, great. Thanks, Stephen. Next question is about brownfield or existing sites. When looking at safety and design for construction in a brownfield substation site, what is the best approach for handling the earthing system? There will be times when the earth conductors will be exposed with no crushed rock and minimal soil. There could also be new and existing earth grids in close proximity that will affect one another but may not be electrically connected.
Yeah, and another good question and a bit of a hot topic. So safety and design's been huge in Victoria for a long time and is certainly pushing everywhere. But construction safety is massive. So there have been some construction safety questions asked in the Queensland market, asked well, and we need to get the right answer to them. I can answer this question in one word. The answer is carefully. There isn't a silver bullet. There is no simple answer, I'm afraid. If you're working on one of the few coal mines in Queensland that has fault limitation on their HV reticulation, then you may be looking at a substation that has an EPR of 20 or 30 volts. The answer there is there's no voltage hazard that I'm concerned about, and there's not going to be much current if there's an earth fault. So your consideration of the best way to work in the brownfield environment probably could focus on other things because it doesn't have to focus strongly on earthing. The focus on earthing should be that I don't want to interfere with the existing current paths, rather than I don't want to be inadvertently exposed to voltages or currents that could divert away from it. You go back to the major supply sub in that same mine and it won't be fault limited and it will have much higher EPRs and higher currents. You've got to decide one of two approaches really. You either are going to become equipotential bonded and you're taking a bird on a wire approach, or you're going to be separated from that voltage rise, the EPR that could occur during a fault. However you do that, they're the two outcomes. So typically it might be that you've decided on an exclusion zone and you are going to operate separated, so you'd install your grid, you'd do other various bits and pieces, but you might have to stay 10 metres away or 5 metres away or 2 metres away until you're ready to become the bird on the wire. And then, using safe work practices, those connections are made so that you're now part of the normal earth grid. In other cases, the first thing you might do is bond into the earth grid with a conductor around the outside and get conductors in to create as close as you can to an equipotential place before you get started with, you know, fences and ATCO huts and equipment and footings and all the rest of it. So we've certainly had cases where it was best to do it either way, or a combination of the two, where you might actually, for a big extension on a transmission yard, you might actually create 2 or 3 work zones that aren't bonded to each other, that have exclusion zones down the middle, and that's the best way to control it in the area. Now, what dictates which one's best? Fault level, existing grid impedance, existing system impedance, but probably the single biggest thing is what the soil makeup is. If you've got a low resistivity over high resistivity soil, then what you will get is very gradual voltage decrease away from the sub, but it will spread a long way. That lends itself more to bird on a wire style. If you've got, on the other hand, high resistivity over low resistivity, then you'll get very steep gradients, and that lends itself more to a separated approach in the construction. Now, in terms of construction safety, when you bond the grid in and how you maintain separation or combination, that's not the only safety consideration. There's a lot of other things about safe working around them, about power supply to your ATCO huts and to equipment, and those things in our, I guess, way of operating, they tend to work their way into a site safety plan for the earthing system on brownfield sites.
Great, thank you. This next question is about measuring touch potentials. So the viewer has heard examples where touch potentials taken outside the substation yards were completed using a test lead connected to the injection point. Measurements are taken from the item to the ground, item to EPR / the test lead, and the EPR to the ground. It is said that this helps with diagnostics and development of a correct solution by identifying what is exactly producing the voltages at this point. Can you go into this in a bit more detail?
I can. Do we know who asked the question?
That was me.
Yeah.
I remember doing it when I was down there doing Safe Earth training.
Okay. My question was going to be, where did you see that? Because it's a good technique, but to my knowledge, others aren't doing it. So yeah.
Well, I tried to tell the boss about it, and they're like, oh, yeah, maybe not. The risk of running the EPR lead out, I don't know about that, so it hasn't been done.
Okay, well, and that's a fair consideration. There are certainly places where we would decide that you don't want to run the EPR lead to a certain location, and we'll settle for just doing other measurements at that location. But let's say you were doing your fall of potential test, you've got the EPR lead out anyway. Let's say you could safely move, 20, 30, 50 metres in either direction. Instead of just taking a touch voltage measurement to a fence 10 metres away from a sub and wondering what created that touch voltage, if you have your EPR lead with you, you can prove what created that touch voltage. So let me paint you a simple picture. We've got a substation that has an EPR of 1,000 volts. We've got an allowable of, say, 400 volts. And when we get to this fence that's 10 metres away from the substation, we measure 500 volts. We've got a non-compliant touch voltage. It's 50% of EPR, and it's non-compliant by 25%. How do we fix it? We could do secondary mitigation. We could put crushed rock on the ground, or we could insulate the fence at that location so it can't be touched. But if we want to do a better job engineering-wise, and this is almost a truism, we need more information. And this is one of the reasons we have engineers doing these tests. If a technician did the test and said, yes, I've proven it's non-compliant, the next thing the engineer's likely to say is, okay, why is it non-compliant? Is the fence picking up a voltage from the substation and transferring it out so that the voltage on the fence is actually higher than the voltage on the ground? It's closer to the EPR at the substation, and the ground voltage, the soil voltage, has dropped away, leading to a 500 volt difference. That's a possibility. Alternatively, this could be a low on high resistivity situation, and the substation voltage could be holding up out to 10 metres away from the fence, from the substation. And this fence may actually go hundreds of metres away down the side of a road. and the fence may be drawing in a remote voltage which is much lower than the EPR and lower than the soil voltage at that location. Now in that case, the ground is the low voltage, and the ground is the high voltage and the fence is a lower voltage. So the same 500 volts is there, but which way was it caused? If it was a transfer out from the substation, then the best mitigation, almost a primary mitigation, is to create disconnection between the fence and the substation. Now it doesn't have to be physically connected, it could be soil coupled transfer, it could be current that's gone into the ground and popped up into the fence close to the substation, or it could be inadvertent or deliberate direct bonds. So there's options there to separate it. If the fence transfer is in from remotely, then the better option is to go further away from the substation and create some additional earthing or some separation points in that fence away. So if we take a fall of potential lead out with us, we can very easily do 3 measurements. We can do EPR or substation grid to the fence, we can do substation grid to the soil, and then we can do fence to the soil. We've got 3 voltage magnitudes, and we can very quickly work out which one's where in terms of those placements. The other thing we can get, and this is a little bit more tricky, is if those 3 magnitudes don't add up in a scalar sum, then that means there's some phase in one of those magnitudes, in one of those voltage vectors. And if we determine that, we then need to work out how did the phase shift get in there. And that often leads us to questions of inductive coupling into things like fences. So if that touch voltage on the fence wasn't simply a transfer out or a transfer in, perhaps some of that voltage was coming because the fault current into the substation ran parallel to that fence for a considerable distance, and the magnetic coupling into the fence is actually producing part of the 500 volts we've measured. That would create some phase shift, and it might be picked up through a 3-point test using the fall of potential lead. So that's something we've been doing for probably 10 or 15 years, using the fall of potential lead. The newer strategy we've got for that now is we actually have remote phase on our meters. So when we measure the voltage between the fence and the ground, we can now determine what the phase is compared to the injection current, compared to the EPR on the substation, and the touch voltages that we measured on the fence on the way out. It means that we don't have to carry the fall of potential lead. It's a little bit harder in your brain to try and work out what's going on at the time, but it gives you access to a lot of information.
Great, thank you, Steve. This is the last of the set questions, but we've got a few. Well, Matt has asked an extra one. So in this one's about...
Too late, Matt, sorry.
This one's about... Yeah, this one's about continued development. You mentioned in your presentation that you were at the prototyping stage of development. How has the development progressed? Have you started testing the application, or what projects have you used it on? And what are the results like? Are you finding grids safe or consistently unsafe?
So yeah, we have continued development, absolutely. There's a lot of work going into it. And the major driver isn't, just the fun of being more accurate or seeing more clearly how to make good decisions. The driver is really so that we can make those better decisions for asset owners. So the area we're using it most commonly at the moment is in the design stage for power utilities. So it's helping us make better decisions about whether major substations should be bonded to the distribution subs they feed, whether there should be bonds at those substations into the low voltage system, which some people would call a CMEN system at the distribution subs, and trying to make those right decisions based on the big picture, not based on one set of traditional voltages. So we are using it. We're still using prototypes in making those decisions. We're finding, I think this is probably a good statement about where engineers are often at. We're finding that the calculations are backing up what the instinct was of the very best engineers in the first place. And I don't think that's a case of a good scorer beats a good player. I think what we're seeing is that engineers who are really good at what they do, who have had a lot of experience and who understand things well, they'll get a gut instinct about what's right or wrong before they can prove to you that it's right or wrong. Then when we do objective analysis, and even if we put it up to other people to do from first principles and make sure that we've not biased the process, we're still finding good support for those instincts. So I've been pleased about that. In terms of existing assets, I think we've seen a mix of safe and unsafe. I think what typically happens when you apply a simple rule across a large set is that the results are, probably between 60 and 80% right, and then you'll get somewhere they're over-conservative and somewhere they're unsafe, not conservative enough. And we are continuing to see that.
Okay, great. Thank you. That's the end of the set questions, but Matt Zillman has asked one through the chat, so I might just get Matt to put that to you.
Hey Steve, thanks for the presentation. It's been very thought-provoking and interesting discussion. My question is a bit of a follow-on from maybe the first two, but with the changing standards, like we're seeing a transition now from the IEEE 80 sort of flatline standard to a more risk-based approach. With that transition, a lot of the substations that were once safe may become unsafe and vice versa. In my very, very limited and probably naive experience, we don't really review the performance of an earth mat until we have to. So until we're going to do some augmentations on a site or going to do some additional work, and we need to ensure that substation's safe. As a business or as an industry, how do we compromise between ensuring the safety of each and every substation compared with the cost of actually doing that and the resource cost of doing that? I mean, to be able to continually be in a state where you're sure all of your substations are safe would be prohibitively expensive, I would assume. So I just wanted to get your thoughts. I mean, are you happy with as you work with that approach, or should we be reviewing them frequently?
Yeah, I mean, isn't this the same problem we spoke about earlier? The lawyers and the people who are focused on them, possibly including the board and senior management, they want us to tell them whether it's safe or not safe. They are seeing black and white, and they think there's, 100% safe situation. In reality, none of them are perfectly safe, 100% safe, no chance of fatality, and none of them are 100% guaranteed chance of fatality. So, no matter how you measure, no matter what stick or rule you're using, then you have assets that have bigger risks associated with them and others that have smaller risks. And that's the same when we talk about the earthing-related risk that's imposed on the public and imposed on our staff. So that's a starting point, is that all of our assets have some level of risk by any measure. Now, when we change the standards, it's very common to have grandfather clauses that say you don't have to go back and change things just because we changed the rules, but if you're going to change something else about it, then you have to review everything about it. So this is as simple as, when we introduced safety switches to the Australian residential market, they didn't have to be retrofitted to every power circuit, but if you put another power point in the power circuit, you had to retrofit one. Now that was step one. That's gone to the point now where RCDs or safety switches have to be on every circuit in a residence, and now they're on nearly every circuit in industrial and consumer as well. But on the very first day when we said they've got to be in all new final subcircuits that are supplying GPOs, there was no question about that being the safest way forward, but it was clearly impracticable to have them instantaneously installed on every circuit through the whole place. So the standards came up with a way that indicated likely practicable application of them over time. That's what we've got to do for our earthing systems as well. So when we kind of say, oh, my understanding has changed about how I should measure whether they're safe enough or whether the risk is low enough, we should be ready to say, now how am I going to roll that understanding out across all of my assets? Now, the way we've done it for utilities that we work with is we've got a fairly high level desktop assessment of all of their assets, and you're almost putting a risk score on them. You know, you can say, look, all of these ones, they don't worry me for these reasons, you know. These ones here, I think we should get to those, but they're not the highest priority. These ones here, we need to assess these for these reasons. Now, that process of almost setting up a priority order for how you're going to hit things, that doesn't only happen when the standards change. That probably should be how we're approaching it all the time. You know, that is the right approach to asset management. So changing standards isn't this broom that comes through and cleans your place out. It's just something that we now need to consider for everything we do next, and we're probably doing next what we were doing before, setting priorities and trying to add value and reduce risk. You know, that's always the process.
Thanks very much for that, Steve.
Jonathan or Matthew Ridgely, did you have any questions you wanted to put to Stephen?
Yeah, Steve, Matt Ridgely here. This one's probably a bit more. There you go. This one's probably a little bit more political, but Ergon's transitioning to EG0, and we're doing pretty good at that. However, we use contractors often for design, and they still could be using IEEE 80. And it also comes in largely when we're looking at safety in design. And previously we've injection tested a substation. It was it's only just fractionally unsafe according to IEEE 80. And then reviewing it via EG0 guidelines, because we never had any proof that the substation was actually ever designed to IEEE 80 anyway. We've reviewed it with EG0 and said, well, actually, according to our standards, which we use now, which is the only standard it's ever been really, truly assessed to, it's safe. So we've gone, right, yeah, we don't have any issues with this. The contractor, go in there and build on it now. Have you ever seen conflicts with one company using IEEE 80 and another company using EG0 about which one is the one to be followed?
I haven't seen a dispute or any real problems. The most common application of EG0 that I'm seeing is utilities and asset owners saying that we want it to be assessed using EG0's methods, and most commonly they also want some comparison to the traditional criteria. I certainly would be asking for that if I was the asset owner, and we're commonly assessing to those as well. If you're using a technique that has been used for 20 years and is producing outcomes that are clearly not offensive to society, that's not a bad checking point for whatever the new method is that has only been applied for a couple of years. So I think
our issue probably comes in that we use EG0 now, and we've gone from saying it's unsafe to it's safe, and it's the contractors. They're going to go in there and start construction. So they're going, well, no, one's saying it's safe, one's saying it's unsafe. So now I want to charge you another $10,000 for mitigation, and we're like saying no, because according to our philosophy, current philosophy is it's fine. So it's more so in that context, so more design versus construction, and which one's really safe. If one says it's safe and one says it's not. Yeah,
look, not to be too cynical about the constructors, but what are they planning to spend the 10 grand on?
Yeah, they just want to put bloody barricading and random stuff in there, and safety means they want to barricade their entire substation off from the public because the fence has high step and touch potentials. And
so look, I'm afraid there's two things to consider, okay? One is what your business might be able to negotiate using, clever tactics and good reasoning and analysis. And certainly I think you could probably win the argument. The other thing to consider is what happens if someone's hurt or killed. Okay? And I'll I'll tell you, there's no worse place to be if someone was hurt or killed than someone else has very clearly indicated to you what precautions they want you to take and what they'll cost, and that you dismiss them based on what standards you were assessing the safety to. Okay? That really does come back into ALARP and safaris. If someone's nominated a precaution and they've got a cost associated with it, then I think the interesting thing to do, and quite possibly the best defensive position if it was to ever become involved in the courts, would be to work out what the risk and what the change in risk associated with that precaution would be. Yep. If you can show that the cost's grossly disproportionate, then I think that's a better explanation to the builder anyway, why you're not paying for it. But if it's not grossly disproportionate, even though you might win the argument with the builder and not pay for it, then perhaps it still should be done, because it might be what the courts expect in hindsight if something went wrong. Yep. Does that make sense?
Yep. Yeah, it does.
So if you want to work through an example of that, trying to calculate the delta risk for that cost, send me an email. I'd be happy to have a look at it with you.
Oh, yeah, well, our substation design group's currently doing a review. That's where I asked the question about whether you do the bed on the wire or isolated system. It's all the same job. So, yeah, our design group is currently doing a safety and review of how to do it. So that'll all be included, I'm sure.
Okay.
So.
Okay, great. Thank you, Matthew. Jonathan, did you have a question? Otherwise, I've got one.
No, you shoot.
Okay. My question's a bit, I guess, philosophical and high level, but since, Stephen, you seem to be dealing with risk every day, I think you could be well qualified to answer it. My question is there any concept of background risk? For example, if you're doing something involving signals or systems, you consider a signal to be, I guess, disappeared when it's 20 dB, or negative 20 dB rather, because it just becomes insignificant compared to the background noise. So is there some concept of background risk, as in the risk a person will face every day going about their lives, that's considered like a base level or minimum that you should try to aim for?
Absolutely there is. In the world of engineering, it's not just signal to noise ratios in comms that's true for. Every single thing we do, there's noise, every single thing. And we do work on the idea that, there's no point, cutting my grass any shorter, there's no point in building that steelwork any stronger, because there's certain things that just can't change no matter what we do. Now, in the legal profession, I don't believe that exists. Okay, we could look at the same sheet of paper and they'll say the sheet of paper is white. We'll look at that sheet of paper and say actually there's microscopic particles on that paper that have various abilities to reflect light, and they're not actually flat and it's not all white. That's the world we live in, unfortunately. So how does it bear out? It bears out that engineers say that there's a risk level which is below the weeds, and they refer to it as a negligible or a de minimis risk level. And people can still argue about what that level is, but philosophically there must logically be some risk level below which we don't care. It's just below the weeds. Now, various attempts have been made to set this de minimis risk level. Some people will call it a tolerable risk, below this it's tolerable, but most of the attempts to set it have been based on a combination of what society, a risk level above which society would want to know why you didn't mitigate it further, and a risk level below which society, if they actually in foresight were assessing the risk, would see it as about the same chances of you being hit by lightning, or the same chances of a number of other conditions and causes of fatality that occur that we don't really do much about. So, if you're in Canada, it might be they might compare it to the death by brown bear or death by cougar. In Australia, it might be compared to, snake bite or other accidental deaths that we're not spending money trying to stop. The difference between the engineered approach and the legal approach is the engineer looks at, you know, what's the chances of injury, how bad could it be, what are the mitigation options, how much will they cost, you know, is it a good use of funds? More often than not, you know, when a local council is spending their money to make the community safer, it's based on what legal action has occurred in theirs or another province and what legal action they think they could end up seeing and what's the best defence they could have against the legal action. So what we see is, you know, kiddies' playgrounds being ripped out and replaced with ones at 10 times the price, but we might not do anything about other things that actually represent a bigger risk to the community. So I think there is a de minimis risk. I think you could argue about whether it's 10 to the minus 6 or 10 to the minus 7. That risk level, I think, which represents de minimis risk is actually different when you consider societal risk or the possibility of multiple fatalities compared to single. But I think philosophically there is this risk level. Now the thing that I think is misunderstood by a lot of lawyers and probably a lot of engineers as well is this risk level that we call de minimis. That's not the risk level at which we do nothing. It's the risk level at which we stop looking for more things to do. If there's something clever that we can do that's affordable, that makes things safer for people, then of course we're going to do it. But the law treats us like, you know, we wouldn't. So I'll give you an example. If you had, you know, if you've got your own child in a situation and they're wandering around and there's something there that, you know, is probably only a 10 to the minus 7 chance of killing them, but it's only you getting off your chair and walking over and picking it up and getting rid of it, you're going to do that every time. And that's the precaution, you know, available precautions approach. So, you know, to a degree, the SAFAR is right. To a degree, the WorkSafe is right, but it's right if it's used in foresight. It's not right if it's used to suggest that what engineers have been doing, including that, is wrong and that we somehow need to change the whole process.
Great, thanks for that answer. I think we'll wrap up the session here because we're pretty much right on time. I just wanted to say thank you very much, Stephen. I know you're a very busy person, so we really appreciate you coming in to answer these questions. I think you've definitely given us all a lot of food for thought, highlighted that there's no simple answers to questions and that we need to use our own judgment and experience as well as just following the standards. And we possibly may have to justify those judgments to lawyers or other non-technical people as well as other engineers. So yes, thank you very much for attending and we really all appreciate it.
No, you're welcome, guys. Good on you and all the best with your careers and your development.
Okay, great. Thanks very much.
Thanks very much, Steve.
Thanks, Steve.
Cheers. Bye-bye.
All right, I just stopped the recording there, but yeah, just really quickly, we'll send out the recording to you before we post it online just so you can review it.
Thank you.
Make sure it's all okay.
Fantastic.
Yep.
And thanks again, Steve.
Yep,
No problem. I
Appreciate that.
I'll have to catch up with you guys next time I'm in Brisbane.
Yeah, definitely.
Okay.
Cheers.
Great, thank you.
See ya.
Bye.
See you all. Bye.
Hey, John, Matt, you still there?
Yep.
Yeah.
Cool. How did you think that went?
Well, I'll speak first. I thought that was a ripper Q&A. I thought Steve's answers were brilliant. I thought that both of you did a really good job running it. It was really slick.
Yeah, cool.
Yeah, I was just glowing with a certain amount of pride, and also thinking that we might have to cancel your trip to the UK, Matt, and we'll have to change you.
I don't know about that. I think, yeah, like great work, Ben. I think you did a really good job of running it. It's definitely, we improved upon a couple of things with Brad's presentation, so that was good. I'll tell John now, I stupidly forgot to start recording about a minute into the presentation. I realised I hadn't started recording.
Were you both recording though?
Yeah.
Yes, but yeah, I don't have admin rights, so I can't. It won't like convert it to the WMV format. I'll save it as something .wmv, but when you try to open it, Windows Media Player goes, hey, I don't have the codec. So we're assuming there's some way to convert it after the fact, but I'm not quite sure.
as long as I can rip the audio from it, all isn't lost. Because I'll just, I'll just overlay the audio onto a couple of pictures of the slides. I mean, I pretty much missed up to where he started talking, so I missed where you asked the question, Ben, and then Steve started talking to answer the first question. So if need be, I'll voice over the first bit again.
Are you going to do different voices and pretend to be me and pretend to be Steve?
Well, I'll just... yeah, I don't know. No, because I've captured the bit where Steve's talking, so we should be all right.
Yeah, all good. Just in regards to other stuff, I updated that Confluence page about those questions to put to the committee. I sort of added a section at the top that is basically just questions that hopefully we can just copy paste and send to everyone. The sort of grouped into 3 areas. I think it was sort of looking back, what our purpose is, and looking forward. And I think it'd be good to just get people to not necessarily answer every question point for point, but use the questions as prompts to sort of write a little bit of a blurb about each of those 3 topics.
Yeah, I agree. Good. Maybe we could throw in a couple of our answers, talking about wins we've had for the past year. We could throw in a couple of things that we put as sort of thought provokers or discussion.
Yeah, I added a few examples. My only concern with just chucking everything is people would just go yep, I agree, and not really add their own thoughts.
Yeah.
Unless we add stuff that specifically we know people won't agree with, then they'll actually start adding thoughts. Just if no one can decide where to go for dinner, you say, hey, let's go to McDonald's. And then suddenly everyone has a suggestion.
Yeah, agreed.
I guess I was wondering, just quickly on that, moving forward.
Yeah.
To what extent do you think we should limit the discussion to the committee? Or to what extent do you think it's worth flagging to everyone that we're going to be working towards election of a new committee? And I guess we've got a bit of a review and planning process, and because I guess I'm thinking that if we'd almost want other people to participate in as well, if there were other keen people, we want them to have a chance to speak up, and also in some ways to think seriously about what's involved moving forward. I'm nervous about if we do this all internally and then we have elections and people put their hand up and they don't really know.
Yeah, that's a really good point.
And you can't kind of vet people. I guess it's also kind of vetting people because, historically we've struggled with people who put their hands up but they're not really that keen to do work.
Yeah.
So it's a way to try and...
Yeah, I agree. I was thinking about that as well, John. I wasn't sure, for example, people like Jeff, who Jeff doesn't hold a formal position, not that there really are that many formal positions on the committee. But I was wondering how you would sort of bring him into the discussion. I think we should open it up as much as possible. If we had people who have expressed some interest, we shouldn't disclude them, like you said.